Okay, what we're covering today is balancing chemical equations. You've had this introduced to you in an Adam Smith activity, actively learn, and Ed puzzle. So this should be the integrative activity that brings it all together. Balancing chemical equations is working towards demonstrating the law of conservation of mass. And if you remember the law of conservation of mass, it says in ordinary chemical reactions, matter is neither created nor destroyed. What that means is the mass of the reactants has to equal the mass of the products, or what goes into the chemical equation has to come out. Now I've made these matrices for you, and my matrix on the board follows it. This is by far, I believe, the best, easiest, and quickest method to balancing chemical equations. And it's not just because I created it. Okay? There's many different methods for balancing chemical equations. I don't care which one you use, as long as you get it correct. But this, I believe, by far is the simplest. So I'm going to walk you through 3 of them, demonstrating how to use the matrix. So, first step, and I highly recommend you do this, rewrite the equation on the matrix. Okay, so if we look at balancing equations worksheet without the number sign behind it. Second side has number 2. We're looking at the side that does not have number 2 on it. Everybody on the correct page?
Both sides have number 2.
Yeah, both sides. Great. No.
In the title. Okay, are we good? So, our first problem is aluminum nitrate reacts with ammonium phosphate to produce aluminum phosphate and ammonium nitrate. So that was step 1, rewriting them at the top of the matrix in those boxes. You want to make sure that they line up with each of the reactant or product. So aluminum nitrate's reactant 1, ammonium phosphate is reactant 2, aluminum phosphate is product number 1, and ammonium nitrate is product number 2. Everybody good so far?
We don't have anything in that one.
Not yet. Everybody good?
Hold on. These markers are way too big. Do you have any smaller ones?
Those are the smallest I have.
Okay.
I know, they've been abused and abused. Okay, if you're having trouble with the matrix, just redraw them on the table. There's a purple one over there too, or a blue one that's a very fine point. You obtained it? Okay, step 2 is you're going to list the elements.
Oh, this is nice.
So in this column here where it says elements, you're simply going to list them. Aluminum, nitrogen, oxygen. We're good so far. Aluminum, nitrogen, and oxygen. Now we already have nitrogen down, so the next one is hydrogen, phosphate. Because we got to list all the elements. Okay, and we already have oxygen up there.
Will there only be 5?
There's only 5, yep. In this example, sometimes you'll have 3, sometimes you'll have 5, sometimes you'll have 4. It just depends on the reaction. Everybody good?
Yes, sir.
Okay, step 3, this is the difficult one. You're going to count the atoms for each element. So, in reactant 1, how many aluminums do we have? 1. We put a 1 down. Now, I purposely did it more to the right side of the cell or the block. Okay? But it'll make more sense in a minute. Nitrogen, how many do I have? 3. It's just like math. Whatever's outside the parentheses, we distribute inside the parentheses.
Wait, what?
That would be 9.
So 6.
How many nitrogens do we have?
3. Oh, no.
We have 1 nitrogen inside the parentheses times 3 is? Now, for oxygen, how many do we have? 9. We are.
Yes, and that's what he.
Oh, I thought someone said 6.
Somebody did, but I didn't write it. Okay, are we good? Nitrogen, how many do we have?
1.
3.
1 inside times 3 is 3. Hydrogen, 4 inside times 3 is 12. Phosphorus,
12. No, 1.
1. And oxygen,
12.
4. Last time I checked, 4 times 1 was? 4. Okay. Now, for product aluminum phosphate, how many aluminums do we have? 1. How many phosphorus?
1.
How many oxygens? 4. Okay. For ammonium nitrate, how many nitrogens?
1.
2.
1 here plus 1 there is 2. Very good. How many hydrogens?
4.
4. And how many oxygens?
5. That's a 3.
3.
3.
I thought it was 5 too.
That's why I said rewrite them on your paper from the worksheet. Are we good? Everybody with me so far?
Yes, sir.
Okay, step 4. Pick the element in least number of columns with greatest ratio. Okay, so what do I mean by least number? Aluminum's in 2 columns. Nitrogen's in 3 columns. Oxygen's in 4 columns. Hydrogen's in how many? 2.
12 and 4. What do you say 4?
It's in this column, and it's in this column.
Oh, I see it now.
2 columns, right? And phosphorus is in 2 columns also. Now the second, so that leaves us with aluminum, hydrogen, and phosphorus. Which one has the greatest ratio?
Hydrogen.
Hydrogen. So that's the one I would start with. Okay, also on a practical basis, 1 equals 1, right? There's nothing to do. So looking at hydrogen, what we are trying to do, and you can treat this yield sign equivalent to an equal sign. We're trying to make what's on the left-hand side of the equal sign equal to the right-hand side.
Why do we put it in that place?
Because that's where the arrow sign was.
Multiply by 3.
This is the difference between the reactants and products.
Multiply by 3.
Okay, I'll get there. Now, I could have put zeros in these empty boxes, but if I did that, it'd make it look a lot busier and a lot more complicated. So I just leave them blank. Now, we have 12 hydrogen coming into the reaction. How many do we have coming out?
4.
So, Abby, what do we do?
Multiply by 3.
Multiply by 3.
Wow.
Now,
Oh, because 4 times 3, so never mind. Got it.
4 times 3 is 12. Now, here's where the magic of the matrix occurs. Whatever we do to one part of the column, we do to all parts of the column. So that means we carry that 3 all the way up. Because there's no way to get 3 sets of 4 hydrogen without getting 3 sets of the compound. Yes.
So if there's nothing in that cell, then you don't do anything. You don't put a 3 there.
3 times 0 would be?
Okay.
Hold on a second. I understand carrying it to the end, right? But why would you carry it to the O? Because the O's not connected to it.
Okay, because the only way I can get 12 hydrogen is if I also get 9 oxygen. Because the hydrogen and oxygen are coming as a package. Okay, this is ammonium nitrate. Ammonium nitrate contains 2 nitrogen, 4 hydrogen, and 3 oxygen. If I want 12,
So that whole thing is.
whole thing's multiplied by 3.
Thank you.
And that's why I write it oftentimes in a parentheses there. Okay, are we good? And it'll make a little bit more sense the more we do it. Okay, so now hydrogen's balanced. Which one do you want to go to next? Aluminum and phosphorus are still balanced.
And
Okay, so N is the next one that's in 3 columns. What's this?
well,
What's this symbol?
Why do you have to do it if they're only in 3 columns?
a plus sign.
Plus sign. 3 plus 3 is?
6.
3 times 2 is? 6. So nitrogen's balanced.
Kidding. Hey, I have a question. Why are we doing just the ones that have 3 columns?
That's the next one. Olivia, all the ones with 2 columns are balanced. 1 equals 1. Right? So aluminum's good. 1 equals 1. Phosphorus is good. Nitrogen was the one with the next least number of columns.
Okay.
Good? Everybody good? Now, oxygen, 9 plus 4 is? 13. 4 plus 3 times 3 is? 13. So it's also balanced.
Wait.
Okay.
You don't
Takes
use
a
that.
lot
Wait,
for
wait.
it.
So
Whoa.
you don't need a 6.
How did you? What's the
Because
You
it was-
start with the one in the least number of columns with the largest ratio.
But wait a second. You said that if it had 2, if it's just in 2 columns, that it was going to be equal to each other. But 12 is not equal to 4.
No, because it's on
12 is equal to 3 times 4.
But you said that they would always be, if it was 2 columns, that they would be equal.
No, I didn't say that. That's where you start. Okay, are we good? Yes, sir.
Will we be getting this table on like the final exam?
No. But I'm giving you this table now. Now, I don't mind doing that because how difficult is it to draw a 6x4 matrix? Pretty easy. And probably the ones you're going to see on the final exam, by that time you'll have had enough practice, you can visually look at it. And you have it, it's multiple choice. So if nothing else, you run through the possible answers and eliminate the obvious ones. Right? Are we good? Questions? Now, previously, what they would do is simply teach you through guess and check. You'd start putting numbers in and trying to see if it balances. And you'd have to do several iterations, and then that would become very tedious and frustrating, and people would give up. This works 99% of the time.
Bruh.
What about the
The other about 1%, you'll end up with one of those, and I'll show you the logic behind doing it.
No.
You got one on the homework or classwork. So that was number 1.
Wait, how do we write it?
So what you write is, if there's nothing that you've done here, it's implied to be 1. So this would be 1 aluminum nitrate reacts with 1 ammonium phosphate to produce 1 aluminum phosphate and 3 ammonium nitrates.
Wait a second.
So that's what's going in those blanks on your worksheet.
You need to be in parentheses. Okay, wait.
No, they do not need to be in parentheses. Now, I don't mind if you leave the blanks blank if they're 1, unless they're all 1s. And if you leave them all blank, I don't know if you did them or didn't do them. Right?
Can we just put a star next to it?
No, just put 1s in
Do
there.
anything to them.